section is going to be on dividing decimals. What's important to remember with dividing decimals is I still want you to estimate your answer, but estimation is going to be a lot more difficult here than it is with any other type of operation. So when you are estimating, you can be a lot less exact with your estimations, even more so than adding, subtracting, or multiplying. And there are some problems where it's very tough to get an accurate estimation. So let's start looking at a few problems. So right here, before we add in any decimals, I just want to quickly review what whole number operation looks like for division. So if we have the number 483 divided by 21, we simply are going to write out the operation this. Now I'm going to do the more traditional algorithm. If you do partial quotients here, that also works, but just for the sake of speeding this video up, I'm only going to do the more common algorithm. So what I'm doing is I'm looking for numbers that divide into, we're targeting here 43, and we want to get as close as possible with a multiple of 21. Well, the highest multiple that doesn't go over is actually 21 times 2, which is 42. And then what we simply do here is we subtract, which gives us then 63. And then the next step, the next multiple here is actually exactly 21 times 3, which is 63. So that means from this original problem, 21 times 23, that's equal to 483. And that's our answer. And that's what whole number computation looks like. And for the most part here, it is not actually going to be any different when we are working with decimals. So let's add a couple decimals into this problem and see how it changes it. Let's change this into 4 83/100 divided by 2 1/10. The first thing we have to do, like any other decimal problem, is we have to estimate. But estimation can get very hard here. So if we estimated this to be 5 divided by 2, what that actually gets us is a decimal estimation. And you can do that, but it's not ideal. So what you have to do is you have to change one of these numbers. And I'm actually going to change the 5. I'm actually going to round this to be a 4 divided by 2, which gives me an estimation of the number 2. Important to remember here that the estimation is less exact when we're working with division. So now that we have the estimation done, let's once again write out the division algorithm and show how that's different. So there's not a really good reason to explain why this happens, but when we are doing the division algorithm, this number, the divisor, cannot be a decimal. Okay? So what we have to do with this problem is we have to change it so that this number is no longer a decimal. And what we are going to do, if we think about, let's do something easy here on the side. Let's do the number 6 divided by the number 2. Well, I hope you know that that's 3. And what I'm going to show you on the right is we can actually multiply both of these numbers by 10 or 100, and it doesn't change the value of the problem. So let's multiply both of these numbers by 10. That turns into 6 divided by 20. Well, 60 divided by 20 still has an answer of 3, as does 600 divided by 200. Therefore, if we change this number and this number by multiplying by the same value, it will not change our answer. So, in order to remove the decimal from this problem, we are going to multiply this number by 10 and this number by 10. So what that changes this into is 48 3/10 divided by straight 21. Okay, and now that this no longer has a decimal, we can simply divide this problem like normal. So what we do is we actually take our decimal, we move it right here, and then we pretend it doesn't exist for the rest of the problem. And since we've already done this problem once before, I'm just going to speed through. And we end up getting an answer of 2 3/10, which is very close to our estimation of a regular 2. So once again, we write our answer like we always did before, and we get through. Now, The actual division part here is not that difficult with these problems, but it is tough to remember that the divisor cannot have a decimal in it. So we multiply both of these terms by the same value to get rid of that decimal. Let's try another. As we move here to our estimation, once again, estimation is very tough here. I'm going to change this number to 7, but you could really change it to 8 as well. And this number is very close to the number 1. Well, 7 divided by 1 is about 7. Now, if you change that to an 8, 8 divided by 1 would be about 8. Both of those estimations would actually be just fine. They're really not that different from each other, and both would be counted correct. When we move to the actual division part of this problem, 7 and 47 hundredths divided by 9 tenths. Once again, remembering that we need to change both of these numbers by multiplying by something to get rid of the decimal. Well, this has one decimal place, so I'm going to multiply both of these terms by 10, okay, which turns this into 9 and turns the number 7 and 47 hundredths to 74 and 7 tenths. Now that our divisor is not a decimal, we are going to divide like normal. We're targeting 74. I know that 9 times 7 is 63, and 9 times 8 is 72. So that is our closest multiple. We then change this into 27, and then it's 9 divided by 3. 27 divided by 9 is 3, so that ends up giving us our answer of 8 and 3 tenths. Now, I'm going to quickly type this in just to double check, because with division, it's very, very easy to make a mistake. We did get this correct. Therefore, 7 and 47 hundredths divided by 9 tenths is equal to 8 and 3 tenths. Once again, noticing that our actual estimation we did was not that close. That is fine. You just need to be in the ballpark, okay, to make sure that your decimal is not in the wrong spot and things like that. Now, here's the number one reason why dividing with decimals is actually a very, very helpful skill. When I do this problem, this is actually pretty close to 0, and we could go 0 divided by 16. That means our answer is actually going to be really close to 0. So with our estimation here, it's actually very unhelpful to estimate, but we now know our number should be very, very small as we work through it. The reason why dividing with decimals is really powerful is this problem normally would actually have a remainder, but when you are dividing with decimals, you never, ever, ever have to have a remainder, which is a very helpful skill. So let's actually divide here. We move our decimal up. Now, we can't divide into the first digit, so we actually put a 0 here. Then we look at 21. Our largest multiple is actually 16 times 1, which gives us 5, and then we bring down our 6. Now, I'm kind of slanting a little bit here, but it's the same idea. Now, 16 times 2 is 32, so then the next best multiple is actually 16 times 3, which is 48. Now, from here, we actually have, in a normal problem, we have a remainder of 8. Now, because we know dividing by decimals now, we get to not have to work with a remainder ever again. We can add a 0 after this problem because we know from earlier sets that adding a 0 to the end of a decimal problem doesn't change the value. So now we do 16 times 4 would be 64. What about 16 times 5? Let's try that. Well, I know that this is 30, and look at that, right on 80. So that means we are done. Now, if this number here did not come out to be 0, we can actually continue this process infinitely. Most problems, like the one you'll see right after this, tell you when you should stop. They'll give you a place to round to. So this is actually 135 10,000ths. It's actually a very difficult decimal to read, but we did get the answer correct. Let's move to a story problem here and start talking about this in real-world context. Over the course of the volleyball season, Ashton made 82 aces. If there were 14 games total, and that should actually be a comma, and that should be a lowercase h. How many aces per game did she average? Round your answer to the nearest hundredth place. Okay, so we know she made 82 aces total, and there were 14 games. That certainly sounds like a division problem to me. Now, when we are estimating here, I know that 14 times 5 is about 70. So then 14 times 6 is 84. So I know that my answer better be around 5 or 6 for our estimation. Okay? So when we work through this problem, we better have something that's in between 5 and 6. Now, because we are working with decimals, we actually do not have to have a remainder at all. So we get to find the exact answer here as if we're working through the problem. Now, I just looked down here that 14 times 6 is 84. So we know that this number here has to be 5, which means our decimal goes right there and right there. 14 times 5, that is 70, which gives us 12 left over. And normally we would be done here, but we can actually add a 0 after the decimal point and not change the value of the problem. Now, this is where it gets a little tough. Okay, so 14 times 9, or 14 times 10, sorry, we know is 140. So if we actually skip count backwards, 14 times 9 should be 126 because we're subtracting 14. So that means this number has to be an 8. Okay, so 14 times 8, that has to be 14 less than 14 times 9, so 1/12. So let's bring that back. And we have 8 left over. Once again, we can add another 0. And remember, we're going to the 100th place, so we're going to have to do this one step further anyway. This is now the same thing we had right away, so we put another 70 here, because we've already done that. And one final 0. So 100. And that actually, it's going to be 14 times 7 exactly. Or no, sorry, 14 times 7 is going to be the closest. That'll be 98. So then we are done here because we wanted the 100th place. So the number we have right now is 5 and 857 thousandths. But we want to round to this decimal place. So it is closer to 5 and 86 hundredths. That is our closest estimation, which was between our two estimations here. So we have to write a sentence. So I'm going to say Ashton averaged 5 and 86 hundredths aces per game. And we are done. A little tricky concept, so it's going to take you a lot of practice to figure it out, but as long as you keep remembering that you cannot have a decimal in your divisor, you can at least find the process through. As always, if you have any questions, please let me know anytime.